Hi guys, and welcome to our third week of distance learning. Today we're going to go ahead and start section 5.4. 5.4, we are going to get to look at some cool formulas that are called the sum and difference formulas. And what these help us to do is to be able to evaluate the sine, cosine, and tangent of values that are not on the unit circle. So knowing that, please make sure that you do have a unit circle handy because we will be looking at this throughout today's notes as well as the rest of section 5.4. Okay, the cool thing is when you are looking at sum and difference formulas, it is just simply a formula. So if I'm looking at the sine and I'm adding two values, you're going to use this formula. The sine, if you're subtracting, it has addition and difference, so sum and difference for cosine and tangent as well. So I think the easiest way to make this make sense is let's just go ahead and try a couple, okay? The example for the first one says to find the exact value of the cosine of 75, right? So you're like all excited and you're looking at your unit circle and you're like, hey, cosine is 75. Crap, there's a 60 and there's a 90, but there's not a 75. So I cannot just simply look at the unit circle and take the x value like I would have been able to in the past. That's where these sum and difference formulas are going to come into play. You want to be able to look and find two measurements that are on the unit circle. In this example, we're going to go ahead and use addition, where I can add the two values together and get 75. So I'm going to say, let's do the cosine of 45 degrees plus 30 degrees. Because 45 and 30 add together to make 75. They wanted us to use addition. And if I look at the unit circle, I can find 45 and 30. Okay, so that's what you're doing. They're going to give you a value that is not on the unit circle. You will either use addition or subtraction to find two values where you can create what they're asking for. Now, when you're doing the formula, you'll notice that there's a lot of A's and B's. A is always going to be referring to the first measurement that you took from the unit circle. B is always the second. So what that means in this example, when they say A, you're using 45 degrees. When they say B, you're using 30. Now keep in mind, addition is commutative. So if you put 30 plus 45, you are going to get a solution at the end that is equivalent to what I get. It might be in a different order, but it would still be considered the correct answer, okay? Now let's look at the formula. So we have cosine and addition, okay? So if you have cosine and you're taking two values and adding them, you take the cosine of A times the cosine of B. So the cosine of 45 times the cosine of 30. Then it's minus sine. I'm just following the formula. The sine of A times the sine of B. So the sine of 45 times the sine of 30. Now here, you're going right to that unit circle. Remember, a cosine is an x value. A sine is a y value. So if I want the cosine of 45, you go to 45. Cosine is square root of 2 over 2. Cosine of 30, you go to the 30. The cosine is the x, square root of 3 over 2. Minus. Now if I want the sine of 45, the sine is the y value. So I take the square root of 2 over 2 times the sine of 30. 30, the sine is the y value, so it's 1/2. Remember, when you are multiplying fractions, you have to take top times top and bottom times bottom. When you're multiplying radicals, you multiply the radicands, the number underneath. So 2 times 3 is 6 over denominators. 2 times 2 is 4. Minus top times top. Square root of 2 times 1 is a square root of 2 over 2 times 2 is 4. Now you are adding fractions. Cool thing is we have a common denominator. The common denominator carries over. These are not like terms. In order for them to be like terms, you would need the same radicand, the same number underneath. So what you have for your answer is the square root of 6 minus the square root of 2 all over 4. Now remember, I said since we are doing addition and addition is commutative. Had I had 30 plus 45, if I would have switched those two, my answer, I would have had a negative square root of 2 plus the square root of 6 over 4. These two things are still equivalent, okay? They're still technically the same answer. I have the same denominator. I have a positive square root of 6 on the top and a negative square root of 2 on the top. So if you are working ahead, just to kind of make sure you're on track, when you're adding, it is possible to have the correct solution just written two different ways. Okay, let's go ahead and try another one. Let's try the sine of 405. So again, you're really excited and you're like, hey, 405. Oh, the unit circle only goes up to 360. Bummer dude. So what we're going to have to do is use addition. We want to find two values that are on the unit circle that I can add up to and get 405. So I'm going to go ahead and say, well, let's take the sine of 315 degrees plus 90. And again, there's lots of different options. As long as you are taking two values that are on the unit circle, and when you find the sum, because they're asking us to add, you find that sum, you get to 405. Okay, so again, lots of different ways. I'm just picking a couple values to go through these examples with you. Okay, this time it's a sine and addition. When they say A, we fill in 315 degrees. When they say B, we fill in 90. So let's check out the formula. Sine of A plus B. So it's the sine of A. A is 315 times the cosine of B. B is 90. Plus the cosine of A. A is 315 times the sine of B, and B is 90. So here is the formula. At this point, all you have to do is go to your unit circle. Remember that when you're looking for sine, you're taking the y value. When you're looking for cosine, you're taking the x. So I'm going to start off 315 degrees is right here. The sine is the y value, negative square root of 2 over 2. Next is the cosine of B, so I'm looking for the cosine of 90. Here's 90. The cosine is the x. X is a 0. Plus, now it's the cosine of 315. So I go to 315. Cosine is a square root of 2 over 2 over the sine of 90. Find 90. The sine is the y value, so it's a 1. Okay, so this is what I have to calculate at this point. Negative square root of 2 over 2 times 0 is 0. Plus, square root of 2 over 2 times 1, when you multiply anything by a 1, it gets to keep its identity. That's that additive identity property from way back in Algebra 1. Here, if you add a 0 to something, it does not change. So 0 plus square root of 2 over 2 is square root of 2 over 2. And again, that's another identity from Algebra 1. That's the additive identity. Remember, what can you add to a value and have it not change? And here is the multiplicative identity. Holy smokes, flashbacks to 9th grade, guys. This would be your answer. So the sine of 405 degrees is the square root of 2 over 2. Anybody else think this is fun? Okay, good. I totally can hear your voices, I swear. Maybe I'm losing it, but it's all good. We're going to do two more, and that's going to be our idea for the day, okay? This time we want to find the exact value. And when they say exact value, what that means is please do not go into decimals. Keep everything in terms of your square roots. Keep them as fractions. So your answers are going to look like this because of the direction saying keep it exact. You don't want to turn it into decimals. Okay, now we're going to go ahead and look at some subtraction. We want the cosine of 15. If you look on your unit circle, there's no 15. Oh no. So what you have to do is you have to figure out two values that are there where you can subtract them and make 15. So I'm going to take 60 and 45 because 60 minus 45 is 15. If you want to go wild, you could go 45 minus 30 because you get 15. And that's what I mean. There's so many different options. Okay, I said I was going to take 60 degrees minus 45, okay? Now here's the deal. When you're adding, you have that commutative property. With subtraction, you don't. You have to make sure that when you subtract, you get to the 15. I can't change the order. I can't take 45 minus 60 and get a positive 15. So here, it does matter. You should get the exact same answer as me, even if you picked the 45 minus 30, okay? Because you had to make sure that these two degree measurements, you did find a difference of 15. Okay, When they say A, we're using 60. When they say B, you're using 45. You do not tag the negative with the 45, okay? So when they say B, it is simply just 45. The minus, what that's telling us is that we are looking at a difference formula. So when we go ahead and look up here, I have to have cosine of A minus B. So the minus sign just helps us to figure out which formula to use. It is not tagged on to the 45 degrees. Okay, let's go ahead. Cosine, I am subtracting. So it's the cosine of A, so cosine of 60, times the cosine of B, so cosine of 45, plus sine. The sine of A is 60, times the sine of B is 45. And again, I just used that from our formulas that are at the top of your notes for today. Now I have to use the unit circle. You have to remember that cosine is the x value. So if I go to 60, the cosine is 1/2. If I go to 45, the cosine or x value is the square root of 2 over 2. Plus, now I get to look for the y values. The sine of 60, that is the square root of 3 over 2. The sine of 45, that y value, is the square root of 2 over 2. Now we're to multiplying fractions, a skill where you've been doing this as well for a very long time. Top times top, bottom times bottom. 1 times the square root of 2 is a square root of 2. 2 times 2 is 4. Plus, square root of 3 times the square root of 2 is the square root of 6. 2 times 2 is 4. When you are adding fractions, you need a common denominator, which we have. That 4 carries on over. These are not like radicals, so I need to keep it as the square root of 2 plus the square root of 6. That's what the cosine of 15 degrees is equal to. One more, and I'm going to send you off for the day. This time they want us to find the exact value of 255. Yay, look at the unit circle. Oh, it goes from 240 to 270. There's no 255. Sad. They want us to use subtraction. Okay, so looking at the unit circle, I was like, all right, if I take the sine of, let's say, 300 minus 45. I know 300 is on the unit circle as well as 45. 300 minus 45 gets me to my 255. Now I have to look at the formulas. So I'm looking at sine and subtraction. So it's right here. So it's the sine of A. Remember, A is the first measurement. So when they say A, I'm using 300. When they say B, I'm using 45. This is the formula I'm using because it's the sine and it's subtraction. So the sine of A times the cosine of B minus the cosine of A times the sine of B. So that's how I'm going to set this up. So sine of A is 300, times the cosine of B, that's 45, minus the cosine of A is 300, times the sine of B is 45. So this is my setup. Now you go to your handy dandy little unit circle, find 300 degrees, which is right here. The sine is the y value, negative square root of 3 over 2. Cosine of 45. 45 is right here on the unit circle. The cosine is the x value of the ordered pair, square root of 2 over 2. Minus, now I want the cosine of 300. Here's 300. The cosine is 1/2. I want the sine of 45. 45, the y value, the sine, is a square root of 2 over 2. So you will notice as you're going through these, your answers always look very, very similar. Where it's going to vary is on the top, where are your positive and your negatives. Okay, so don't be alarmed if it feels like you're getting the same answer all the time. Negative square root of 3 times the square root of 2 is a negative square root of 6. 2 times 2 is 4. Minus 1 times the square root of 2 is a square root of 2. 2 times 2 is 4. Again, we have our common denominator. Heck yeah. Carry that 4 over. These are not like terms, so I have a negative square root of 6 minus a square root of 2. And that is our first day of week 3. I hope you guys are doing well. I hope you had an awesome Easter. Maybe you had to do an Easter egg hunt or eat a lot of chocolate. Either way, I hope you had a good time. I will talk to you again tomorrow, guys. Miss you.